let us see the methods to control the surging. Before this, few things must be clear to us. That is how to draw the velocity triangle, which we have already seen in the lecture. Second thing, how inlet guide vane changes the angle at the inlet, right? And how it affects the velocity triangle. That also we have seen. Third thing is, if certain parameters changes, for example, blade velocity or axial flow velocity changes, then what will be the effect on velocity triangle? That also we have seen, right? So if compressor is running at the lower speed than the design, then what will happen? CA is very high at the rear stage and CA is very low, axial velocity is very low at the front stage, right? So then relative angle is very high for the front stages, right? So those blades may get stalled, right? That is positive incidence stalling. And in the rear stage, CA is very high, so relative angle will be very less, right? So what we have to do, we have to increase the blade velocity for the rear stage and decrease the blade velocity for the front stages, right? For that, we can split the compressor in different spools. So for example, this is multi-spool compressor. So 2-stage, it is shown here. LPC, HPC, low pressure compressor, high pressure compressor, right? Then what we can do, we can run this low pressure compressor at low speed such that blade velocity U will be less and beta will get reduced, right? This we have seen in the lecture also, how it is reducing, how it is affecting the velocity triangle, right? Similarly, we can run this HPC at higher speed because at rear stage CA is very high. We have to increase the blade velocity to increase the relative angle, right? So this is the first method. Second method, that is variable inlet guide vane. Purpose of inlet guide vane, we have already seen how it is affecting the angle, relative angle at the inlet, and how it is decreasing the relative velocity at the inlet of the rotor, right? So that is already discussed, right? Third thing is bleed air. So if certain blades are stalled, then mass flow rate will be less through that, right? Then if we bleed the air, if we bleed the air from the downstream stages of the stall blade, it will increase the mass flow rate, right? And it will increase the axial velocity. When axial velocity increases, you can see the velocity triangle, you can check your notes. Blade relative angle at the inlet of the rotor blade will decrease, right? So this is the third method, right, which can control the stalling or surging.